This lesson is about using tangent, sine, and cosine to find unknown sides of a triangle. But let's start out here. What side is adjacent to angle N? Okay, so here's angle N right here. Adjacent means right next to. So we're looking for the leg that is near. Don't use the hypotenuse. That's something special. So the side that is adjacent is the MN. Okay, that's the adjacent leg. What is the hypotenuse? Well, that's NL. Okay, there's your hypotenuse. Calculate the cosine of L. Well, remember that the cosine is adjacent over hypotenuse. The adjacent leg, that is, over the hypotenuse. So that means the cosine of L, okay, if I'm looking at angle L now, then from that perspective, 8 is adjacent, and 10, of course, is the hypotenuse from the perspective of L. Okay, so that's going to be 8 over 10, which reduces down to 4/5. Okay, now if I want to talk about the cosine of N, all right, now I'm looking at angle N. Cosine is adjacent leg over the hypotenuse. So again, we're talking about the adjacent leg over the hypotenuse. All right, but this time that's going to be 6 over 10, which reduces down to 3/5. So there's cosine of angle N. All right, let's move on. Find the sine, cosine, and tangent of angle A, this shaded angle up here. Let's start with the sine. Okay, of course the sine is the opposite leg over the hypotenuse. Okay, so from the perspective of angle A, there's my opposite, and here is my hypotenuse, so 12 over 13. Okay, the cosine is the adjacent leg over the hypotenuse. Adjacent means right next to, so still dealing with angle A, there's my adjacent leg, and there's the hypotenuse, so 9 over 13. And last but not least, tangent. Tangent is the opposite leg divided by the adjacent leg. Still dealing with angle A, here is the opposite leg, and here is the adjacent leg, far and near, so 12 over 9. Okay, but 12 over 9 reduces down, dividing both of these by 3. That's going to be 4 over 3. Okay, so there's the sine, cosine, and tangent of angle A. Let's move on. Now, so we can use this type of information to solve triangles, to find unknown sides. So what is x? Well, first we have to decide which function we're going to use. The angle that we're given right here is the 52. So from the perspective of the 52, what is this 18? Opposite, adjacent, or hypotenuse? Well, that is adjacent because it's near the 52. What about this x? What's that? Well, that's the opposite leg. All right, this over here is the hypotenuse, but we don't have any number, there's no x there. So these are the two things we're going to deal with. So we have x is the opposite leg, and 18 is the adjacent. Opposite, adjacent. Which trig function is that? That is the tangent function. All right? We know that the tangent of some angle, of any angle, is the opposite leg divided by the adjacent leg. And that's what we have here. So for this specific case, that means the tangent of 52 degrees is going to equal opposite over adjacent, x over 18. So it's just a matter of solving this for x. Well, the easiest thing to do when x is in the numerator like this is just to multiply both sides by the denominator. So multiply both sides by 18. These 18s will cancel each other out. That's going to give me x equals 18 tangent 52 degrees. But this is something I can simply put in my calculator. 18 tangent 52. Okay, so here I go. I just type in 18 tangent 52 degrees. All right, so that's 23.0 rounded to the nearest tenth. Okay, so x is 23.0 units. Okay, and that came from just putting that into my calculator. Now, how long is the hypotenuse of this triangle? Now, they don't have a variable on the hypotenuse waiting for me. So I'm going to call it h. Okay, so imagine that the hypotenuse is h. Maybe I'll put a green h on there. Okay, so h is going to be my hypotenuse. Now, I need to again decide which function I'm going to use. Okay, I still have to use that 18 because that's the only one I've got. It's the only actual number I've got. So 18 is still adjacent. Okay, but of course, h here is my hypotenuse. So I've got adjacent and hypotenuse. Which trig function involves adjacent and hypotenuse? Well, that's the cosine function. The cosine of any angle is the adjacent leg divided by the hypotenuse. Okay, so if I want to find the hypotenuse, this is what I'm going to have to use. So specifically, the cosine of 52 degrees, okay, is equal to the adjacent leg, which is 18, over h, the hypotenuse. Now, notice my variable is in the denominator. I taught you guys a shortcut for getting the variable out of the denominator in a situation like this. Do you remember what it is? I taught you that anytime you have a fraction equal to something, you can swap the denominator. It has to be the denominator. You can take it and swap it with the thing that the fraction is equal to. Okay, if I do that, then this is going to become h equals 18 over cosine 52. Okay, this is the hypotenuse. The hypotenuse equals 18 over cosine 52. So that's the quickest thing to do. Anytime the variable is in the denominator, you're going to want to make this swap. It's legal. And now this is something that I can simply put into my calculator. 18 over cosine 52. So 18 over cosine 52. Let's 29.2. Okay, so those are the answers to this problem for x, and that's the hypotenuse. Okay, let's move on to the last two problems. What is x? Once again, we have to decide which function we're going to use. From the perspective of the 16, the 24, what is that? Is that opposite, adjacent, or hypotenuse? 24 is adjacent. See how close it is to the 16. This would be the opposite leg way over here. And of course, x is the what? It's the hypotenuse. Okay, see how it's across from the 90? X is the hypotenuse. So, what have we here? We have adjacent and hypotenuse. So once again, that is the cosine function. Okay, the cosine of an angle is the adjacent leg over the hypotenuse. So in this particular case, that means cosine of 16 degrees is going to equal 24 over x. All right, once again, I see that the variable is in the denominator. What am I about to do next? I am about to swap the denominator with all this. So this is going to become x equals 24 over cosine 16. Okay, and this is something I can just put in the calculator. 24 over cosine 16. 24 over cosine 16. All right, that's 24.96. That's going to round up. But when you round up a 9, that's going to affect this. So this is going to become 25.0. Okay, so that's x. All right, now, how long is side ij? Okay, ij is the opposite leg. I'm just going to go ahead and call this y. Let's just call it y. Okay, so if we look at this now, all right, we still have to deal with the 24 because that's the only one that we've got. But now we're dealing with this y. Okay, so we're dealing with adjacent and opposite. Okay, because this is the hypotenuse up here. We already dealt with that. So, but this time we're dealing with the adjacent leg and opposite leg. Opposite and adjacent. Which function is that? Well, my friends, that is the tangent function. The tangent function is defined as the opposite leg divided by the adjacent leg. So in this particular case, that means, whoops, almost put another theta. That's a Greek letter theta, by the way. We use that as a variable to represent angles very often in geometry. But this time we have a real angle, so 16 degrees again. So tangent of 16 degrees is going to equal opposite leg over adjacent leg. So y over 24. Okay, do I need to do any swapping here? No. That would just put the 24 over here and the tangent 16 down here. I wouldn't be any closer to getting y by itself. Instead, what am I going to do? Hopefully you said, let's multiply both sides by 24. Okay, if I multiply by 24, those are going to cancel each other out. So that is going to give me 24 tangent 16 is equal to y. All right, but this is something I can just put in my calculator. So 24 tangent 16, let's do that. 24 tangent 16. So that's 6.88, 6.9. Okay, so y is equal to 6.9. All right, and that is side ij, because I call that y. All right, and that is the end of this assignment.